Hello folks, let's get started with yet another problem of this exercise 7.4, which is a problem number 19. All these problems, we saw it in the 18th problem also, and all the upcoming problems, they're going to be like that. You will have a linear in the denominator. It's for us to check whether the linear is a derivative or not. If it's a derivative, it relaxes us, but if it's not a derivative, then you have to bring the derivative into the picture, and then in that case, the entire integral breaks into two parts, and then you have to calculate the integral. So that's going to be the work, and therefore it's going to be a little voluminous affair. Every problem is going to be like a bit voluminous because we have to take care of all this. So let's get started right away. And to make matters worse, here they have given the denominator as a factor, not as a quadratic. So we have to do that additional work. So let's consider the denominator, see what they say. The denominator is x minus 5 times x minus 4. When we open it up, it is x squared minus 5x minus 4x plus 20. That is x squared minus 9x plus 20. It is for us to check whether the given numerator is the derivative of the denominator. Let's check. So when you take the derivative, it is going to be 2x minus 9, which is not the derivative. This is not the derivative. So that means we should convert it in the form of the derivative. So let's do that here. 6x plus 7 is maybe a times 2x minus 9 plus b. This is how we convert it. A and b. Bring the a and b into the picture. And then, it's because of this a and b that you get two integrals. Okay. So, see, it's very clear to us. Here there is an x part and a number part. So, that way we should segregate this part also. Make it an x part, make it a number part. So, this is like 2ax minus 9a plus b. So, this is the x part, this is the number part. So, if we actually correspond, therefore 2a is 6 and b minus 9a is 7. So, a is dividing by 2, 6 over 2, it's 3. A is 3, but what is b? A is, b minus a is 3, so minus 27 is 7. So, let's take the 27 on the other side plus 27. 7 plus 27, it's 34. So, we got a and b. That's good actually. So, what happens is we have got 6x plus 7 now as a times. That is 3 times 2x minus 9 and 34. Okay, that's one part. We have one more issue to settle. That is, anyhow, you know that over the fag end, we'll have to do completing squares for x squared minus 9x plus 20. So let's do that also and keep, so that when we start the integral, we are able to do it at one flow. So also, let's look at x squared minus 9x plus 20. I have always told you that make it as x squared minus 9x and keep the 20 away so that we can complete squares. And in completing square, I told you that here it's 1 because x squared doesn't have a coefficient. So basically we are having 2ab equal to 9 actually, out of which a is 1. Means a is a coefficient of the x squared term. Here the x squared term is 1, so a is 1. So therefore you are having 2b as 9 because a is 1. So b is becoming 9 over 2. We know that in completing squares, we are adding and subtracting b squared. That means you're adding and subtracting 81 over 4. You're adding and subtracting always b squared. So adding and subtracting means we don't want to change the value. So we will add and subtract so that you get your desired form at the same time. You don't change the value of the expression. So we have got this expression now, and let's see now how to work on it. Here this is like denominator 1, so make it over 4 because we want common denominator. So this part is now very clearly x minus 9 over 2 the whole squared. Yes, it's always b which will come there. And here when we solve, it's 80 minus 81 over 4. That's minus 1 over 4. So it's like x minus 9 over 2 the whole squared plus minus 1 over 4. So it is x minus 9 over 2 whole squared minus 1 over 2 the whole squared. Minus can come out. Plus into minus, minus. So it's minus 1 over 2 the whole squared. Something of the type x squared minus a squared. Root of log Yeah, log x plus root of x squared minus a squared plus c, simple one. Yeah, so here itself, let's make that small note, so that this is actually the integral is log x plus c. All this we have observed and kept. Now let's go back to our integral. I is now becoming 6x plus 7 is getting converted like this. So instead of 6x plus 7, we are writing 3 times 2x minus 9 plus 34, and this root x squared minus 9x plus 20 dx, which we are separating 3 times 2x minus 9 dx over this. So root of x squared minus 9x plus 20 and 34 outside, integral of dx over root of x squared minus 9x plus 20. Perfect now. So when we come back, it is going to be 3 times du over root u. And this is 34 integral dx over root of x squared minus 9x plus 20. Now we are done. We have everything with us. We know that du over root 2 is 2 root u when the integral comes, and here we have completed the squares and we have called it as, let's write that, we have completed the squares already and we have called that as x minus 9 over 2 the whole squared minus half the whole squared. Its integral also we have found out and kept. So that's it. So your work is 3 times 2 root u, because 2 root u is a derivative of integral of 1 over root u. So 2 root u plus 34 log, shall I write it down? That's better. Plus 34 log x minus 9 over 2 plus root of x minus 5 times x minus 4 plus c. Or coming back, 6 root u for us is root of x minus 5 times x minus 4 plus 34 times log x minus 9 over 2 plus root of x minus 5 times x minus 4 plus c. That's it. So that's how the voluminous, so many things to take care of. Make the numerator in terms of the derivative. Then in that case, then go for the completing squares, keep all that ready, and then come back to the integral, split the integral into 2 parts, and then get the final value of the integral. So that's how we have done this. All the upcoming problems, 2 or 3 upcoming problems, they are going to be like that, where we are going to deal with those problems in the same approach, and it is going to carry this entire steps. You have to do it in so many steps. So that should be all for this problem. Maybe with the next problem, one at a time, we'll be meeting in the next video. Thank you.